already know everything.
Look, girl.
Did you even push on the
What'd you do?
I said something.
I want that one. Let me get that one. I like that one. He's a ninth grader. Yeah.
He's a ninth grader. Thank you. Thank you.
God, it literally don't matter what color it is.
Yo.
Here, take the two.
Yo, you're in high school. Stop acting like children. Okay. Thank you, Josh. Thank you, Gabe. All right, let's get started with today. Thank you for Ari for passing out the papers that I asked Michaela to pass out. Oh, I thought you were. My bad. Yeah, I misunderstood. That's my bad. All right. So, as a quick reminder, okay, the stipulation or the requirement of us staying within these groups is that you work proactively throughout the entire class period. If I start to see a group that is not being proactive because they're focusing on their social life, that group will very quickly be split up. If it becomes evident throughout the class that the majority of groups or even half the groups aren't being proactive, we're just going to have to switch groups up. Is that clear?
Yes, sir.
Okay. Kyson? Sir? Put that away. We need to be focusing on the math we're learning today. So, we did take a transformations unit. About 9 of us were gone last Friday, which means that you do not have a grade currently in the grade book for that transformations unit. You need to make it up by Wednesday. If you do not make it up by Wednesday, you will be taking it in class and losing out on instruction for trigonometry, which is the next unit that we are doing. My suggestion would be if you have a class period where you know you're not doing a ton, to come in and make it up then. Let me know ahead of time. If you can, make it to after school tutoring or before school tutoring to take the test. Vast majority of us did pretty darn well on that test. Those of us that were here on Friday. So, that is not to say don't study, because I'm pretty sure the ones who were here last Friday were the ones who are actively working and studying. I think the grade was like a high C, a 78 or 79, something like that, which is a pretty high test grade.
Wait,
score.
that's the highest one I got?
No, that's the average.
Oh.
I think the average was a 78 or so.
As a whole class, right?
For all that were here. Because if you weren't here, obviously I don't have you factored into that. So, that means that it was a fair test. Does not mean that it was an easy test. I obviously did not pass the test back yet because quite a few of us have not taken it. So, Matthew, I'm talking. So, as I said, you need to make up the test. If you haven't made it up by Wednesday, you will be taking it in class on Thursday, which means you will be missing out on the new content we are covering, and you need that new content. So let's see. We have the bell ringer already completed, so let's go over that bell ringer. Because there are some important concepts involved in that we need to recap before we move into the new unit. Y'all, me taking 10 seconds to collect this information is not an invitation for you to start talking about whatever you want to discuss. Obviously, the first question is pretty easy. Just what is one fun thing the person to your left, maybe I should have said clockwise, because that's really the direction we were going, did over Thanksgiving break. Ate and I slept. Yep, I believe that. Did that as well. Ate food. I've seen mac and cheese specifically show up multiple times. It's like mac and cheese, like the Thanksgiving thing for some of y'all.
Yeah.
See, for me, it is all about that mashed potato life. That and pecan pie. And not just like mashed potatoes out of like a bag, like homemade. Yeah, pecan pie.
Yes.
No, pecan pie. Pecan pie is the greatest pie ever. You can disagree, you're wrong, but okay. Ate Thanksgiving. Ate and slept. hung out with a friend, just lying in bed, getting that sleeping time in. Me and Gabe went to Florida. Alright. Me and Kyson went to Florida. I guess I know who that
She went
is.
horseback.
Somebody did nothing. Played Call of Duty. I feel like that's a Bashar statement, if I ever heard one. Is that not Bashar? You didn't play Call of Duty?
Mac and cheese.
He was mac and cheese?
Yeah.
Alright. So, a lot of fun stuff. Black Friday shopping. I don't know about y'all, but guys, I can't do Black Friday shopping. I can't wait in those lines. I will lose my everywhere I saw had lines like, whoa. Okay, so, I need everyone's attention. Hey, gentlemen, up here for the math. So what is everything you know about similar figures, right? Talk with those in your group to confirm you have covered all ideas. So angle measures and the orientation are the same, but the rest are different. What does that mean that the angle measures are, if they're the same? They are congruent. Okay, so the angles are what? Congruent. Angles are congruent. The angle measures are equal. Okay. They're created by dilations, but they have the same overall shape. Are they the same? No. Similar figures the same?
No.
No.
They're slightly different.
They're slightly different in what way?
Size.
The size. Remember, what do we multiply to dilate? What is the term for the thing we multiply by? Scale factor, right? The thing we multiply by to dilate is called a scale factor. There's a couple other things I really want to hit on that we're missing. Same shape, are congruent, constant ratio. Okay, here's a really important discussion point. Are the shapes necessarily larger or bigger? They could be, but they could also be smaller. When do they become smaller?
When less than 1?
When the multiply by what?
Less than 1.
If you multiply by a value less than 1, and I will say there's a slight modification on that. It has to be between 0 and 1. Because if you multiply by -3, will that make it bigger or smaller? Bigger. It's going to cause what's called a reflection as well. Multiplying by a negative causes a reflection. But it also multiplies by 3, which makes it bigger. So, last detail that I really want to hit on out of this as a reminder before we get into today's lesson. Please hear me very clearly on this. What we have up on this board, everything we know about similar figures, is important for the unit that we're about to start on trigonometry. Which I know, that's a long word. Who's already a little freaked out? Gabe is. That's fair. Tarian is. Alright. Kelsey is. Please hear me very clearly on this. It's just a word. Just because it's a big word does not mean it is a complicated subject. Anybody have an idea what trigonometry is going to deal with very heavily?
Triangle.
Okay, it does have to do with triangles, but I'm talking about based on this bell ringer.
Shape.
Is there anything about triangles up here?
Shape.
Similar figures, right? Yes, it is actually going to very heavily cover triangles, specifically one type of triangle, but it comes down to similar figures, which I feel like overall we were okay with the concept of a scale factor and it scaling up or down, right? The stretching or compressing, but that's what we're going to very heavily cover. So let's go to the lesson for today. Okay, now hear me very clearly on this. Today, the beginning of it should be super simple. As long as you are trying, you can be successful in the lesson we're about to start. Okay? So first off, MVP 4.8, are relationships predictable? That's all we're looking at before we get into what are called trigonometric ratios. And I do want you to hear me very clearly on this. If you ever leave off the word ratio from that trigonometric there, it will mess you up because you'll miss out on a really important concept.
Wait, what did you just say?
If you leave off the word ratio from this idea of trigonometric, right? You can say trigonometry, but really what we're talking about are trigonometric ratios. If you leave off that word ratio, you're going to miss out on some important information. And you will misunderstand some of the important concepts involved in this. Because you have dealt with ratios. Ratios are something that we've already handled both in middle school and last unit when it came to scale factors and dilation, stuff like that. If you can remember the idea of a ratio, you're going to be okay in this unit. So here's the objectives for this first lesson. This is the sheet of paper that Ari passed out. Here's the objectives. We need to be able to identify the lengths of a triangle that are opposite from and adjacent to a reference angle, and we have to be able to identify the hypotenuse. What's the only kind of triangle that has a hypotenuse? Right triangles. Right triangles are the only triangles that have a hypotenuse. We've actually even talked about this earlier when we talked about a really important theorem. Right? The Pythagorean theorem, remember, was a squared plus b squared, where c was the what? Hypotenuse. That's the whole thing, is that the c always had to be the hypotenuse. It had to be across from that right angle. And so what we need to figure out is, okay, so how do we identify what our opposite and adjacent to is called a reference angle? Alright, and then it's all going to be about creating ratios between the lengths of a right triangle to discover relationships between the angle measures. So, here's how we start. In your notebook, right, and so this is on 4.8, you will want probably a separate sheet of paper, which I can pass out paper in a second after I give instructions if you need it, but hopefully most of us have a sheet of paper. Make sure this goes with 4.8. Okay? Can you what? Pass what out? So London has paper if anybody needs it to go with 4.8. Just throw up your hand if you need a piece of paper so she's not talking the whole time. Okay, so just throw up your hand if you need a sheet of paper. She'll bring some to you. Okay, while London's passing that out, I do want to quickly note, I do not have a big ideas graphic organizer for you today. I will have that tomorrow because you need it to help you organize the information in this unit. It's for these instructions, right? Notice it says in your notebook, draw a right triangle. Hey, I have a lot of people talking, looking around, and not looking at instructions, and then they're going to look at me, Matthew, later and say, I have no clue what's going on. Correct, because you weren't paying attention. I'm giving you instructions. Pay attention. In your notebook, draw a right triangle with one angle of 60 degrees. Hear me very clearly on this. This is not a sketch. You have to accurately draw a right triangle with one of the angles being 60 degrees. If you do not do that, then you will miss out on what this entire lesson is about. That is why you have this protractor in your hand to help you correctly draw a 60-degree angle, or a right triangle with a 60-degree angle. Now, does it tell you what the lengths of the sides need to be? No. Should you have the same exact triangle as everybody else in your group?
No.
No. In fact, it's a valid guess, actually, to say yes, but you actually shouldn't. You will actually discover more if everybody in your group has a different size triangle. So try to make sure that they're different sizes. You just have to make sure that the triangle is both a right triangle and one of the angles is what? 60 degrees. You need a right triangle that has an angle of 60 degrees. After that, you're going to measure each side of your triangle as accurately as you can with a centimeter ruler. And then we're going to use the 60-degree angle as the angle of reference. Right? So what I mean by that is, right here, I need everyone's attention. So here's my right angle. Which one is possibly closer to 60 degrees? Up here or right here?
The one that's on the, what's it called, the A.
Up top? Next to, between A and C? Okay. So this would probably be closer to 60 degrees. So what we're going to call that is my reference angle. Okay, so we call it theta. Typically in math, we use what are called Greek letters to represent angle measures. You can also call this angle B. Anyone want to take a guess why this is angle B?
Because no, I don't know. Nobody knows.
What side is opposite it?
Oh.
Side what?
B.
Side B. So angle B is opposite side B. So what angle would this be? What's it opposite from? C.
Okay.
Okay? And so then what would this angle be? A. So remember, the angle goes with the side that is opposite it. That is the best way to understand it. And so you can call that angle B, or you can call it angle theta. And then to help you figure out the rest of these, so do we have any questions about what I mean by opposite?
I don't have a question.
Okay? Alicia, can you give me a different way to describe what I mean by opposite here, if this is angle B and this is opposite it? Any other ways that we can describe that word, or that idea? No idea?
Use it a word.
It could be a word or a phrase.
Reverse.
No.
Okay, reverse could be opposite, but definitely not in this triangle.
Vertical.
Say that one more time. Can we say it's across from?
Yeah.
Right? Theta, or B, is across from that side. So you can say opposite or across from. Alright? Now, this is actually where most students get really tripped up, and I need you to pay attention to this, and I need you to put this away. Do you want to take a 0? So then why are you copying someone else's work? It's because I only caught you here. Put that away. I don't know whose that is. I don't want to know. Put it away. So, opposite means across from. What do you think we mean by adjacent? If side B is across from, which side is going to be adjacent to angle B?
C? No.
So, why C and not A?
Oh, that's what I meant to say.
Yeah. That's what we
I had, I was looking at the one at the bottom.
Okay. But why is it, so you're thinking A now?
Yeah.
So why is it A and not C?
Because C is
I don't know.
adjacent. I don't know.
What do we mean by adjacent?
It's like, boom. Never mind.
I don't know what that boom, I don't know what that means. Come on, what's another way that we could say adjacent to something else? One thing I will say to maybe help you figure this out is your neighbor lives adjacent to you. What do I mean by adjacent?
Across.
Side.
No,
Next
from.
Beside or next to. Okay? Keeping that in mind, I mean, side C is adjacent, right? It is next to angle B. Side A is also next to angle B. So which one is adjacent?
Both.
Kind of. What's the other angle, the other side we're looking for?
The hypotenuse.
The hypotenuse. So which one is my hypotenuse here?
The angle.
The side.
Side.
A.
Why do you think it's side C, Brooke? Okay, the hypotenuse is typically the
It's
longest.
the well, whatever they're called. Across from the 90-degree angle.
That's the bigger thing, because here's the thing I want you to remember. In this case, which side is my hypotenuse?
A and B or A and C?
You can't have two hypotenuses, do you?
There's no right angle.
B.
Say it again, Kelsey.
There's no right angle.
There's no right angle.
But it says I have here.
So is there a hypotenuse in this case? No. And so, Brooke, this is why I don't just say, hey, the hypotenuse is the longest side. Because B is the longest side for sure, but that's not the hypotenuse because I don't have a what? A 90-degree angle, right? The hypotenuse, I need you to hear me very clearly on this, is across from or opposite from the 90-degree angle. So across from right angle. And so a thing to keep in mind about the adjacent side is technically how many sides are adjacent?
One.
I mean, just next to. How many sides are next to? But one of them is the what?
Adjacent. Oh no.
One of them is the hypotenuse. So adjacent side is next to, but not the hypotenuse. With that fundamental understanding of those terms, the rest of this becomes very accessible, right? So we're going to use our 60-degree angle as our angle of reference. We need the sides that are adjacent to that, we need the hypotenuse, and we need the side opposite to that to create these three ratios. And now all you have to do is create your triangles. So I'll be coming around checking. If you need me to check and make sure that your triangle is correctly drawn, let me know. I'll wait a second for you to finish writing notes. Yes?
Oh, nothing.
Okay.
What are you talking
What are you talking about?
Anybody have any questions up to this point?
So,
Yes, ma'am.
we can't just draw a right angle down like what with the.
So here's the thing, like you could draw a triangle that you think is right, but one, do I know that this is a right triangle?
Yes.
What do I need to use in order to make sure I have a right triangle?
Where?
Oh.
The 90-degree angle. The little box.
Okay, if I draw a box in here, yes, that would make it 90, but I'm saying like, or I would be telling you it's 90, but I'm asking right here and right now, is that a 90-degree angle?
No.
How do you know?
There's no
It's
box.
not, no, it's not a 90-degree angle because it's in a box in the corner of the two.
Okay, so the box signifies, what you're talking about is this, signifies it's a right angle,
Yes.
but what I'm saying is, if I'm looking at it right here,
Yes.
Yes, it's a right angle.
how do you know?
You don't.
You don't. What do you need to do to make sure it's a right angle? You gotta use a protractor. This is my point, is if you don't use the protractor to make sure that it's an accurate 90-degree angle and an accurate 60-degree angle, you will miss out on the point of this lesson. Which means you're going to miss out on the most fundamental part of trigonometry. So you have got to make sure that you are doing a 90-degree angle and a 60-degree angle. Any questions before we get started? After you do your drawing, continue by identifying these lengths, creating the following ratios, and start on number 1. I'll be coming around checking in on us regularly. But are there any questions before I release you? Going once. Going twice. Let's get to work. Come on, heads up.